Hello and welcome to Unit 3 review test. The first thing we're going to take a look at is to determine whether or not a list of ordered pairs is a function or not a function. So if we look at number 1, what we're really looking at is these values here. And what you should notice is that they go 1, 2, 3, 4, 5, 6. None of the x values repeat, which means that this is a function. Again, for number 2, we're still going to look at these values here. And what you should notice right away is that -4 repeats, which means that this is not a function. When you're given a table, you're still looking at the same thing. Does the x values repeat? And we can see that for number 3, it goes 2, 3, 4, 5, which none of them repeat, which means this is a function. For number 4, we can look and see, well, right away we see -6, -6. It repeats. This is not a function. As we're moving on down the page, we're still trying to determine if something is a function. So for number 5, what we're going to do is called a vertical line test. We create a vertical line and we're going to run it across the graph. And what you should notice is at no point in time does the line touch more than once. So that means that this is a function. When we look at number 6, we're still looking at the same thing. Does it repeat or touch in more than one spot at a time? And while it looks like it might be close, we can't for sure say that it does. So for this one, it passes our vertical line test, which means it is a function. However, when we look at number 7, you can see that as we run the vertical line across the graph, it immediately touches in 2 different locations at the same time, right there and right there. When this happens, it fails the vertical line test and it means this is not a function. The next section that we're going to take a look at is to determine what the independent variable is versus the dependent variable and explain why we think that. So when you're looking at a graph, the first thing that you should notice is that the independent variable is always going to be the x, whatever the x is. So in this case, it's time weeks. So if we consider that the independent is weeks, that means that the dependent value has to be the y value. So it's going to be the amount of money. And so we're just going to title the dependent is going to be money. And if you think about this logically, if we're looking at this graph, we can see that it's going up, right? And so the amount of money over the amount of time is going up. So what we're going to say is y is that. So the money depends on the weeks. And when you look at this problem, just stand back and take a look at it. That would make sense. This may be someone's they're saving money. It's actually titled right here that they're saving money. So they're saving more money as more weeks go by. And so if they put back a set amount each week, which is what is happening here, as the time or the weeks goes by, the more money they're saving. If we look at number 9, it's talking about Drew's scuba tank. He has a scuba tank that he's swimming with. And again, the same thing. The x value, time, in this case minutes, is going to be the independent value. Again, the x is always the independent. And so that means that the y has to be the dependent, so air. And as you think about it, like if someone's swimming underwater and they have a scuba tank that they're breathing out of, the more time that they're underwater, the less air they're going to have, which is why it's going down as we go across the graph. So again, for the same reasons as the first one, air is dependent or depends, air depends on the amount of minutes. Now we're going to move on down to another section, and we're going to talk about how to determine if something is linear or nonlinear. When we're looking at a table, the first thing that you should consider when you're determining if something is linear or nonlinear excuse me, is the constant rate of change. See how this goes +1, +1, +1? And then this side goes +2, +2, +2. It has a constant rate of change. And because it has a constant rate of change, that means that this table is linear. But when we look at number 11, we can see that it goes +2, +2, +2. So the x side is constant, but on the y side it goes +5, +2, +3. So it is no longer constant. The y side is no longer constant. See how it goes +5, +2, +3. That's not a constant value when you consider that the other side, the x side, went +2, +2, +2. So that means that this table is nonlinear. When we look at an equation to determine if something is linear or nonlinear, in this case we're looking for, does it say y equals mx plus or minus b? And of course it does. So you have y equals 3x plus 10. So it's written in a slope-intercept form, which means that this is linear. Looking at a graph is my favorite way to determine if something is linear. Is it a straight line? And in this case, it's a curvy line, so that means it is nonlinear. As we move on to the bottom section, we want to determine how to write an equation from the following ways. So if we look at a table, how do I determine what the equation is for that particular item? So the first thing I want to do is I want to look at, well, right here x is 0, which means that the y-intercept is 3. So I have to know two things when I'm writing an equation. I wanted to write it in the form of y equals mx plus or minus b. And in this case, b stands for the y-intercept. And on our table indicates that the y-intercept is 3. So we need to know what slope is, the m. So how you're going to figure that out is find the constant rate of change. So here it goes +1, +1, +1. And here it goes +2, +2, +2. And so we know that slope is rise over run. And if you think about a graph, the y values determine the rise. So the fact that it says +2 on the y value means that 2 goes on top and 1 goes on the bottom. So the equation that you're looking to write is y equals 2x plus 3. Excuse me. Now the reason I got 2x instead of 2 over 1 is I can reduce 2 over 1 to just simply 2. So the equation that you're looking for is y equals 2x plus 3. When you're looking at a graph, you still need to know what the y-intercept is and what slope is. And so the y-intercept is where it crosses the y-axis. So when we look at this, we can see that this crosses right at 4. So we want to put 4 as our y-intercept. Now, I can see that there's a point right here really close to the y-intercept, so I'm going to use that to demonstrate how to find the slope. And so the first thing I want to do is I want to find the rise. It goes up 2. So 2 is going to be the top number for our slope. And then we look at the run value. It is 1. And so 1 is going to be the bottom number for our slope. And then I'm also going to check and see left to right, it's going up the graph, so it's going to be a positive slope. So when I write the equation, I want to make sure that's 2 over 1 positive. So the equation is actually going to be y equals 2x plus 4. Again, you'll notice how I reduced the 2 over 1 to 2, and it gave me slope-intercept form. Looking at the second graph I have here, you can see that I still need to know what the y-intercept is, and I also need to know what the slope is. The slope, or the y-intercept for this problem, is right here at the origin. And we know that the origin is 0. So now we got to find the slope. I can see that right there's another point. And so if I check, the rise is 1 and the run is also 1. So I have 1 over 1, but if I check left to right, my line is going down. So it is a negative 1 over 1. And it's going to reduce to negative 1. So when I write the equation, I'm going to write y equals negative x. And you notice I didn't write the 0 and I didn't write the 1. So in mathematics, you don't have to write the number 1 in front of any variable because we assume that there is at least a 1 there. And then if you think about the 0, if I put plus 0, anything that you add 0 to is just going to be itself. So if I have negative 1 and I add 0 to it, it's going to still be negative 1. If I have 5 and I add 0 to it, it's still going to be 5. So there's no need to write plus 0 at the end there. Looking down at the next section, we're going to determine, is something written in slope-intercept form? And just to remind you, slope-intercept form is that equation y equals mx plus or minus b, and where m is slope and b is the y-intercept. So I look at this problem for number 17, and I say, is this written y equals mx plus b? And I can clearly see that it is. So the answer here is yes. Now, number 18 is a little bit tricky for a lot of people, so I'm just going to write this out. If I wrote the equation y equals 0x minus 12, it would be the same actual problem. And the reason being is 0 times x is simply going to be 0. Minus 12 would come down, y equals goes here. And so the reason that it works that way is because 0 times anything is 0. So then I have 0 minus 12, which is going to give me y equals negative 12. And so this is a yes. Yes, it's written in y-intercept form, even though it doesn't have an m or an x. And so I look at number 19 and I think, okay, is it written y equals mx plus or minus b? And it appears to be written that way. The only problem is there's an exponent, and I'm not allowed to have an exponent for linear equations. So this is a no. It is not linear. And then we look at number 19, and I see that I've got these absolute value signs, which means basically that none of the answers will come out to be negative. Well, as you know in a graph, there are negative numbers on the y-axis and on the x-axis, which means that this is not going to be linear because it's not going to allow those negative numbers to appear. When we look at number 21, we have y equals negative x minus 5. And this is similar to something that we've seen before written. So this is written y equals mx minus 5. Or minus b, however you want to look at it. So this is written that way. And we look at number 22. It does not start y equals, so that tells you right away that this is a no. This is not y-intercept or slope-intercept form. When we look at number 23, it looks like it could be, except for this 2. We're not allowed to have numbers written there. So this is a no. We cannot have a 2 in front of the y. Otherwise, it would not be written in slope-intercept form. Now, can we change this to where it is written in slope-intercept form? We absolutely can. I can divide this side by 2 and divide this side by 2, and I can get y equals 1/2 x plus 5 over 2. And now it's written in slope-intercept form. So while this question is asking if it's in slope-intercept form, a previous question might have asked, is it linear? And in this case, it would be linear, but it is not written in slope-intercept form. Looking at number 24, we can see right away it's written y equals mx minus b. So this is a yes. Yes, it's written in slope-intercept form. Looking at the final problem that we have, there's a couple things it wants to know. It wants to know what the slope is and what the meaning of slope is. And then it wants to know what the y-intercept is, and it wants to know what the meaning of the y-intercept is. And then it wants the equation for the graph as well. So the first thing I always find is the y-intercept. So I'm going to look and I'm going to see, well, it crosses the graph on the y-axis right there at 20. So the y-intercept is, for me, is going to be 20. And the meaning of the y-intercept is very similar in all of these, but the first thing, you have to have context for the problem. So it says the floor number, and it says time in seconds, and we're talking about an elevator ride. So based on the context of what I know from the title of the graph, from the title of the y-axis, and the title of the x-axis, the y-intercept means that we start on the 20th floor. Now, I've got the y-intercept. The next thing I want to find is the slope. So I'm going to look at my graph, and I'm going to notice that, again, it crosses right there at 20. So I'm going to find the next closest one, which happens to be right there. Again, excuse me. So, I'm sorry, it crosses right there is the next closest one. We can see that the rise for this problem is going to be 2. 1, 2. And so I know that the top part of my slope is going to be 2. The bottom part, on the other hand, is going to be the run. So I'm going to measure from there. And it counts 1, but let's make sure, yet down here on your x-axis, you'll notice that while it is just one space, it's counting by 2s. So the bottom number is actually going to be a 2 as well. It's one thing you got to be careful about. Check the numbers on your side. Make sure that you're counting by what it says. And then left to right, we can see that it is going down. So it's going to be a negative 2 over 2, which, if we think about that, that reduces to negative 1. And I'm going to leave it as a slope this time, negative 1 over 1. And the meaning of slope. So the top number, if we think about it, is the difference in the y. It's the change in the y. And so the floor is going down 1 for every 1 second. So the meaning of slope is the floor goes down, the elevator goes down, the floor doesn't go down, the elevator goes down 1 floor, goes down 1 floor every second. And hopefully that makes a little bit of sense. An elevator drops a floor a second. We don't spend a lot of time in the elevator, so it's a pretty fast elevator though. So 1 floor every second. And so I've got a slope of negative 1 over 1. I've got a y-intercept of 20. I've explained the meaning of slope. I've explained the meaning of the y-intercept. Now it wants me to write the equation. And so for the equation, I would simply write y equals the slope, negative 1. I'm going to reduce it to negative 1, x plus 20. And you'll notice I wrote the negative 1 this time. It's not necessary. You also could have written y equals negative x plus 20, and it indicates the same thing. Well, I appreciate your time for watching my Unit 3 review. Please take the time and study and prepare for your test this Friday.